With giant storms, powerful winds, auroras, and extreme temperature and pressure conditions, Jupiter has a lot going on. Now, NASA's James Webb Space Telescope has captured new images of the planet. Webb's Jupiter observations will give scientists even more clues to Jupiter's inner life. According to NASA, Jupiter's depths will provide a unique window into the planet. The mission will study Jupiter in the infrared spectrum and map out its composition. Once scientists complete this data, they'll be able to deduce what happens during huge storms on the planet. NASA also reported that Webb will help them find water and ice in some of the most distant corners of the solar system. In addition, Webb is going to be able to find more planets that might harbor life and contribute toward tracing how these alien organisms are related to Earth life. "We hadn't really expected it to be this good, to be honest," said planetary astronomer Imke DePater, professor emerita of the University of California, Berkeley. DePater led the observations of Jupiter with Thierry Fauchet, a professor at the Paris Observatory, as part of an international collaboration for Webb's early release science program. Webb itself is an international mission led by NASA with its partners ESA and CSA. "It's really remarkable that we can see details on Jupiter together with its rings, tiny satellites, and even galaxies in one image," she said. These images come from the observatory's near-infrared camera, which has 3 specialized infrared filters that allow us to see details of our own planet. Since infrared light is invisible to the human eye, these maps have been converted into visible colors you can see. Generally, the longest wavelengths appear redder and the shortest wavelengths are shown as more blue. Scientists collaborated with citizen scientist Judy Schmidt to translate the Webb data into images. The scientists are using a computer program called the SEDS processing engine to extract from the Webb data images of how much infrared light is emitted by different molecular gas, dust, and stars. Molecular gas is atmospheric molecules such as CO, H2, and O2. Dust are grains of matter released into space by stars. Stars with high mass and luminosity also release a large amount of dust and molecular gas. The structure of stars is determined by the temperature, pressure, and chemical composition of their interiors. The interior of a star is hot because it has a high temperature, but it is under relatively low pressure. In contrast, the outer layer of the star has high temperature but moderate to low pressure. Back to Jupiter. In the standalone view, created from a composite of several images from Webb, auroras extend to high altitudes above both the northern and southern poles of Jupiter. The auroras shine in a filter that is mapped to redder colors, which also highlights light reflected from lower clouds and upper hazes. A different filter, mapped to yellows and greens, shows hazes swirling around the northern and southern poles. A third filter, mapped to blues, showcases light that is reflected from a deeper main cloud. The Great Red Spot, a famous storm so big it could swallow Earth, appears white in these views, as do other clouds, because they are reflecting a lot of sunlight. A fun fact about Jupiter's red spot is that NASA is conducting a new study led by a team of international scientists. Has found that the Great Red Spot on Jupiter is shrinking and no longer resembles a storm. In fact, it's transforming into an oval shape. The findings were published in Nature Geoscience. The brightness here indicates high altitude, so the Great Red Spot has high altitude hazes, as does the equatorial region, said Heidi Hamel, Webb interdisciplinary scientist for solar system observations and vice president for science at AURA.
The numerous bright white spots and streaks are likely very high-altitude cloud tops of condensed convective storms. By contrast, dark ribbons north of the equatorial region have little cloud cover.
In a wide field view, Webb sees Jupiter with its faint rings, which are 1,000,000 times fainter than the planet, and 2 tiny moons called Amalthea and Adrastea. The fuzzy spots in the lower background are likely galaxies photobombing this Jovian view. This one image sums up the science of our Jupiter system program, which studies the dynamics and chemistry of Jupiter itself, its rings, and its satellite system, Fauchet said. Researchers have already begun analyzing Webb data to get new science results about our solar system's largest planet. Data from telescopes like Webb doesn't arrive on Earth neatly packaged. Instead, it contains information about the brightness of the light on Webb's detectors. This information arrives at the Space Telescope Science Institute, where it is unpacked, processed, and analyzed. This is done before sending any data off to Webb's Mission and Science Operations Center. STSCI processes the data into calibrated files for scientific analysis and delivers it to the Mikulski Archive for space telescopes for dissemination. Scientists then translate that information into images like these during the course of their research. While a team at STSCI formally processes Webb images for official release, non-professional astronomers known as citizen scientists often dive into the public data archive to retrieve and process images, too. As it was, citizen scientists had already pre-processed and scrubbed the initial image of the Webb telescope as it arrived at STSCI. It is likely that these images have been processed by citizen scientists. stated the press release. The non-professional astronomers will help analyze and categorize objects in order to provide public access to the night sky. He said, the public in turn will be able to tag and share the images they create with their friends and family.
Judy Schmidt of Modesto, California, a longtime image processor in the citizen science community, processed these new views of Jupiter.
For the image that includes the tiny satellites, she collaborated with Ricardo Huso, a co-investigator on these observations, who studies planetary atmospheres at the University of the Basque Country in Spain. Schmidt has no formal educational background in astronomy, but 10 years ago, an ESA contest sparked her insatiable passion for image processing. The Hubble's Hidden Treasures competition invited the public to find new gems in Hubble data. Out of nearly 3,000 submissions, Schmidt took home third place for an image of a newborn star. Since the ESA contest, she has been working on Hubble and other telescope data as a hobby. Something about it just stuck with me, and I can't stop, she said. I could spend hours and hours every day. Her love of astronomy images led her to process images of nebulae, globular clusters, stellar nurseries, and more spectacular cosmic objects. Her guiding philosophy is, I try to get it to look natural, even if it's not anything close to what your eye can see. These images have caught the attention of professional scientists, including Hamill, who previously collaborated with Schmidt on refining Hubble images of comet Shoemaker-Levy 9 seconds Jupiter impact. Jupiter is actually harder to work with than more distant cosmic wonders, Schmidt says, because of how fast it rotates. Combining a stack of images into one view can be challenging when Jupiter's distinctive features have rotated during the time that the images were taken and are no longer aligned. Sometimes she has to digitally make adjustments to stack the images in a way that makes sense. Webb will deliver observations about every phase of cosmic history. But if Schmidt had to pick one thing to be excited about, it would be more Webb views of star-forming regions. In particular, she is fascinated by young stars that produce powerful jets and small nebula patches called Herbig Haro objects. I'm really looking forward to seeing these weird and wonderful baby stars blowing holes into nebulas, she said. If you enjoyed today's video, please leave your thoughts in the comments section, and if you haven't already, hit the subscribe button so that we can produce more videos like this. Thank you everyone for watching, and see you in the next video.